Welcome back for our final installment of Lewis structures in organic chemistry. I noticed I missed a bond in the previous video. Try to find where number 10 belongs. Some of you may have noticed already and have sent me emails. There it is. A sigma between an sp3 oxygen and an sp3 carbon. Oxygen being sp3 because it has 2 sigma bonds and 2 lone pairs. Carbon being sp3 because it has 4 sigma bonds and no lone pairs. Now for geometry. I've added these items here. Here's our bond angles, and here are our possible geometries in organic chemistry. A much simpler list than your inorganic 1 list. Atom A is an sp2 hybridized carbon, and every sp2 hybridized carbon will have the same geometry. I know it's getting crowded here. Bear with me if I miss 1 or 2. sp2 involves getting 3 things as far apart from each other as possible. The angle will be 120 degrees. When those atoms are all, when those 3 things are all atoms, we call it trigonoplanar, which is not on my list yet. Bear with me. There's your updated list. Moving on to atom B. An sp carbon is always linear because it is getting 2 things as far apart from each other as possible. And I see 2 more sp carbons. Linear, 180 degree angle. 2 things can get further apart from each other. C, a carbon that is sp3. I believe I have 2 of those. Now have 4 things to get as far apart from each other as possible. That means the angle is smaller, 109.5, and the name of the geometry is tetrahedral. We also have sp3 oxygen in this example. When describing the geometry of getting these 4 things as far apart from each other as possible, do not include the description of the lone pairs. Keep in mind the angle for all sp3s is always 109.5. The geometry, when 2 of the corners is missing, is called bent. I believe I have 1 more of those here with this oxygen. And I'd like to close by pointing out my molecule. I know it doesn't have a nitrogen, so why don't we put a simple little molecule of nitrogen in it for an example, because it's a common atom in organic chemistry. We have a simple molecule like methylamine. Remember, nitrogen's characteristics are that it forms 3 bonds with 1 lone pair. And if I had to use my labeling here, I have an sp3 carbon, clearly. and an sp3 nitrogen. Remember, you count sigma bonds and lone pairs. Nitrogen has 3 sigma bonds and 1 lone pair, that is 4 things. Carbon has 4 sigma bonds, no lone pairs. We have another sigma sp3, sp3. We had to label it on this molecule. We would do this. We have a sigma s-sp3 for all hydrogens. And we've done all of the bond types. The geometry of the carbon is clearly tetrahedral. Nitrogen, we're going to need a new category. It's pyramidal because it's sp3, but one of the corners is missing. Don't get me wrong, that lone pair pushes the H's and the C away. Otherwise it would be flat. Pyramidal in sp3 environment is 109.5. And we'll just put nitrogen. And there you have it. Walter White would be proud. You just did methylamine. Complete analysis according to this problem. Congratulations, this is a major problem on test number 1, and it shows up again in future tests unannounced. So be ready. Good night.